What if I told you the reason some of your students are learning slowly isn't because they aren't smart, it's because they're thinking like everyone else? Welcome to This Explainer, designed specifically as a professional development guide for academic instructors. Today, we're going to completely dismantle everything you thought you knew about student effort and academic success. We're going to see why the people who learn 10 times faster aren't actually working harder, they're just playing a completely different mental game.
So let's just dive right into this. Why do the students who study the hardest, the ones pulling all-nighters and passively highlighting entire textbooks, sometimes fail the absolute worst on exam day? Well, most people treat learning like consumption. They read texts, they watch videos, and they take really exhaustive notes. But from a neuroscience perspective, information is not learning, and exposure is definitely not mastery. Your brain simply doesn't reward passive input.
Here's the truly uncomfortable truth. Your students are trapped by the fluency illusion. It's this cognitive trick where they mistake the easy, familiar processing of information for genuine mastery. Here's something totally counterintuitive to tell them. If something feels easy to learn, you're probably not learning it deeply. Real learning actually feels slow, frustrating, sometimes even painful. But that friction, that's your brain literally restructuring itself.
To help you break this metacognitive barrier and build elite, self-regulated learners, we'll quickly run through these 6 areas: the fluency illusion trap, embracing desirable difficulties, spacing out the learning, the protege effect, the journey metaphor, and finally, habits for active recall. All right, let's jump right into Section 1, the fluency illusion trap, and see exactly why passive consumption is destroying retention.
So, there's a massive difference between encoding fluency and retrieval fluency. Encoding fluency is that deceptive ease of reading a really clear text or following a perfectly delivered lecture. It creates a psychological trap. Because the words just flow, students get a totally false sense of confidence. Researchers call this a foresight bias. Retrieval fluency, on the other hand, is the actual brain sweat required to remember that information when the book is closed. When students just reread, they build encoding fluency. But our assessments? They test retrieval fluency.
And this brings us to the impact of self-regulated learning. For this cycle to work, learners have to correctly identify what they actually know, and more importantly, what they don't know. They need to accurately monitor their progress instead of just assuming they've got it based on that false sense of fluency. If they rely on faulty cues, like how easy it is to recall something exactly 2 seconds after reading it, they're going to stop studying way too early.
So, how do we actively disrupt this false confidence? That brings us to Section 2, embracing desirable difficulties in your classroom.
You see, top performers don't ask, "How can I understand this?" They ask, "How fast can I get this wrong?" Real intelligence is built through error-driven learning. The exact moment a student thinks they know something but gets it wrong, their brain receives the vital feedback it literally needs for a neural upgrade. Every mistake is feedback. Without that initial guess and the subsequent error signal, the brain's neural weights just don't optimize.
The crucial takeaway here is that we have to instruct our students to abandon those popular, comfortable habits. Rereading, cramming, dragging a yellow highlighter across a page, they feel easy, but they yield incredibly weak learning. We have to replace them with desirably difficult strategies like self-testing, spaced practice, and self-explanation. Yes, they feel harder in the moment. Yes, students will resist them at first, but they force the exact effortful processing required for durable memory.
Let's keep building on this with Section 3, spacing out the learning.
You know as well as I do, students love to cram. But look at the difference between a flawed mass practice schedule, just cramming the night before, and a distributed practice schedule, spaced across days and weeks. Spacing out practice allows time for memory traces to consolidate and for contextual cues to vary. When students revisit material after a delay, they have to engage deeply again. That friction, that terrible feeling of almost forgetting, is exactly what strengthens the retrieval pathway.
To help students accurately monitor their knowledge and expose their own gaps, we need to consistently model this metacognitive feedback loop. Wait, generate, validate. First, wait at least a few minutes or even days. Second, actively generate the information from memory, no notes. Finally, validate by checking the work. This loop absolutely destroys the fluency illusion because it proves to the student, in black and white, exactly what they can and cannot recall on their own.
Moving right along to Section 4, we unlock an incredible psychological tool for deep comprehension, the protege effect. Average learners just chase answers, but elite learners build systems. As this quote from John Nestoisko's 2014 study demonstrates, expectations change everything.
When students engage with material expecting that they will have to teach it to someone else, their retention and structural understanding just skyrocket. Why? Because teaching forces clarity, and clarity immediately exposes any gaps in your logic.
During the performance phase of learning, leaning into the protege effect or doing self-explanation transforms passive reading into a highly efficient system-building exercise. Cramming keeps you stuck in the illusion, but self-explanation forces you to break ideas down into first principles and connect concepts across fields. You're not just memorizing anymore, you are actively restructuring your entire knowledge system.
But to sustain this level of high-effort study, we have to look at Section 5, the journey metaphor. Because learning speed isn't just a technique problem.
It's actually an identity problem. If a student sees themselves as, "I'm just bad at this," or "I learn slowly," their brain is going to act accordingly. But framing an academic goal as an active journey rather than a disconnected container fundamentally shifts that identity. Research shows that when students visualize their goal as a destination on a sequential path starting today, they adopt the identity of, "I am someone who figures things out." That belief alone vastly increases their motivation to push through the struggle.
Let's make this highly actionable for your classroom right now in our final section, Habits for Active Recall. As educators, you can immediately empower your students by explicitly building these habits into your lessons. Swap highlighting for the blank page method. Use frequent low-stakes quizzes, not to grade them, but to expose their knowledge gaps and shatter that fluency illusion. Prompt them to teach concepts to appear. And this is huge. Utilize visual organizers. Having students map out concepts visually builds incredibly strong mental schemas and reduces cognitive load. And lastly, explicitly teach them that these fluency illusions exist so they know what they're fighting.
So here's the ultimate mental model to take away. Learning is not about adding knowledge, it's about reducing confusion. Every concept your students don't understand is just a missing link. So the next time they feel stuck, don't let them slow down. Teach them to lean into the confusion, make mistakes faster, think deeper. Because the people who learn fastest in this world aren't simply the smartest, they are the ones who have trained their minds to adapt, question, and rebuild relentlessly. Thank you for joining me for this explainer. The tools are now in your hands. Will you let your students stay comfortable in the illusion, or will you teach them to embrace the friction?